Hi everyone, this video is on exercise 12b from PO2, and in this video I'm going to do part A of the first question. Because all of the parts are the same, they're conceptually the same, the only difference is that the number is different. Okay, so in part A, basically we have the function f of x is x squared, and we want to use the definition of the derivative. When they say definition of derivative, they're basically saying use differentiation from first principles, and this is the formula of that we need to remember. So obviously, many of you probably know how to differentiate this in the usual way, but this is more like, a proof of that. So that's why we need to learn this, because it's also common to have questions like this in the exam, as well as the usual differentiation that so we can't use that for this question. Okay, so now this we need to use this formula, and we can begin by writing f dash of 2 is equal to, because remember what this question is saying is that find the derivative of this function when the x coordinate is 2. So it's giving us a specific point and is asking us to find its derivative. So in this case, we start by writing f dash 2, and then let's use the formula. So the limit of the function, but obviously since the value of x in this question is 2, instead of writing x plus h again, we can write 2 plus h minus f of 2. We just substitute the value of x over h. So we want to find the limit of this function as h tends to 0. And for the next step, we just need to understand that the function that we have, f of x, is x squared. So when they say f of 2 plus h, that just means that you do 2 plus h squared, right? And then same thing with f of 2. F of 2 means 2 squared. So let's use the definition of the function here. And then as a result of that, we are going to get, still we have this limit as h tends to 0. But now we can substitute the values into the function. So 2 plus h squared minus 2 squared. And at this point, we can then just keep simplifying and going forward and see what happens. So 2 plus h squared is going to be 4 plus h squared plus 4h minus 4. And so we have 4 and minus 4, which they cancel out. And we are going to have limit of the function. So let's write here actually. The limit of h squared plus 4h over h as h tends to 0. And we can also simplify this further. So because we have h in the denominator, that simplifies with this h and then this h on the power. So we are going to basically get limit of h plus 4 as h tends to 0. And then this limit is very simple, because it just means that what happens to h plus 4 as h tends to 0. So it's kind of like, it's very similar, but it's not exactly the same. It's like saying that if you substitute 0 here, what happens? But basically the actual meaning is that if the value of h is getting very, 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 very close to 0, but not 0, but very close to 0, then what's the value of that very small value plus 4? Basically the answer is 4, right? Because as h tends to 0, that gets extremely small, and then its value is basically almost negligible. So that small value plus 4 is just 4. And therefore, this is equal to 4. And 4 is the derivative. So it's the derivative of x squared at 2. And obviously, those of you who know how to differentiate x squared, it makes sense, because x squared differentiates to 2x, and then you differentiate 2 into 2x, and you get 4. All right, that's it for this video, and thank you for watching.